talk to you about queues in data structures and algorithms. So, what is a queue? A queue is a linear data structure that follows the first in, first out principle, which means that the element is added first to the queue is the first one to be removed. Also, a queue has two main operations. What are they? They are enqueue and dequeue. So, what do you think is enqueue? Enqueue is the operation which adds an element to the end of the queue. And what is dequeue? This operation removes the element from the front of the queue. Next, we are going to talk about how queues can be implemented. Okay, so how can queues be implemented? Queues can be implemented using arrays or linked lists. Some common applications of queues include job scheduling. So, what is job scheduling? In this, jobs can be added to a queue and processed in the order they were received. Next, we are going to talk about another implementation which is called breadth first search. In graph traversal, a queue is used to store the nodes that need to be visited next. Next is traffic control. In this, a queue can be used to store cars waiting to enter a highway, with the cars at the front of the queue being the first to enter the highway. Another method we can implement queues are printing tasks. In this, print jobs can be added to a queue and printed in the order they were received. So, overall, queues are useful in situations where elements need to be processed in the order they were received. Okay, so what is queue? It stores elements of data. Of data are stored. Next, the first in first out method is used in the queue's data structure. To understand what is the first in first out method, let me explain you with an example. Okay, so let's consider that there are many students queuing up to enter a classroom. So I'm going to say that the classroom is on this side. Then, so the first student A will enter the queue for the classroom. After student A, student B will enter the queue for the classroom. And after student B, student C will enter the classroom. And after student C, student D will enter the classroom. And now, when you are permitted to enter the classroom, the first student who can enter the classroom is student A. So the first person who can enter the classroom and exit the classroom is student A. Student A was the first person to enter the queue and is also the first person to exit the queue. In other words, first person in is the first person to exit. It is important to note here that whenever a new person is added to the queue, that person can be added to the back of the queue. And the students who are let out from the queue and into the classroom all deletions of the queue are always made at the front of the queue. Okay, so simply let me repeat again. So all additions occur at the back of the queue here, and all the deletions occur at the front of the queue. So how does a structure like this help us in the real life? So queues have major applications. One such major application would be the instruction queue in any computer. So when the computer has given a set of instructions, the first instruction it would execute would be the first instruction that would have come into the computer. And so instruction and computers work in the principle or method of queues. And with that, we come to an end of queues in data structures and algorithms. Thank you.